still a few minutes early, so I'll wait till the minutes. What about 140? 140? Yeah. 140? It's kind of random, not completely random. Okay. So, most programs, BS. So I think some of you are 44, is that right? It's called K44. Some are K45. Who's 44? Those are 44, 45. Yes. They look more nervous. They must be 45. Okay, so the third year students are 44. Fourth year, second year students are 45. Yeah, so you're taking, you've had classes like 140 so far. You've had also EAS 207. 208, there's going to be 230, 204, you have 204 already? 206 maybe? Okay, do you remember? You don't know. Nobody can remember. Okay, well, it's okay. But at the Buffalo campus, the University of Buffalo, these classes, the students normally would all take in the second year. These 140 that we're in today, that's something students normally take in the first year. The second two digits aren't so important. I think they're sort of up to random. So 40 doesn't really mean anything. Kind of like a telephone number. Random. The first two digits, plus 84, plus 1, okay, that tells you where it is. After that, it's random. All right, well, let's start. So, Xin Chao. Bangkok Play Pop. Bangkok Play Pop. Alright, my name is Professor Book, and if you wonder how to pronounce it, it sounds exactly like book, only with book. classes begin with 1, second year classes begin with 2, as you saw. Okay, so this is a first year class. It's the version of the class that we're going to do in here will be a little bit different from Buffalo, because in Buffalo, the first year class includes the students from all engineering majors, right? And they haven't even selected yet which major they will go in. So all of you have already chosen mechanical engineering, right? You're not thinking about chemical engineering, you're not thinking about electrical engineering. Those people are losers, idiots, right? All the smart people are in mechanical engineering. So we don't have to even worry about those. But this course in Buffalo, most of this course is mixed across all of the engineering. So what we're going to do here will be quite a bit different. Okay? Now, why do I keep talking about Buffalo? Because the advanced program that you're in is supposed to be a copy of the program in Buffalo. Right? The bachelor's degree program in Buffalo. So what we're going to spend a lot of time on in this class, we're going to think about what it means to be an engineer. Why do we do this? Right? What's the point? And I'm going to ask you in a minute. Okay? And also, then study the curriculum, because I think you should be a good consumer. A good consumer wants to make sure you're getting what you're paying for. Right? So you're supposed to be learning mechanical engineering. Is the curriculum a good match for what it means to be a mechanical engineer? So by doing this exercise, you're going to learn about the curriculum that will help you to be more successful later. And it will also make you realize more about the profession of mechanical engineering, where perhaps you're going to be working for the next 40 years, or 50 years. Are you having fun? Why are you here? It's a nice day. You could be surfing, could be playing foosball, hacky sack, internet games. Right? Why do you want to be a mechanical engineer? So I'm going to do this randomly. So let me start, if you don't mind. I'll ask you first. Why do you want to be a mechanical engineer?
Because I want to learn mechanical engineering, and I want to be technology engineer, something about machines.
Something about machines primarily. Okay. How about you? Why would you like to be a mechanical engineer?
I think mechanical engineering have broad applications.
Broad applications?
Every I think in life nowadays we need a machine to do anything.
Need machines to do anything.
Mechanical creators.
Okay. Okay, who else? Okay. Okay. What industries do you think you might work in? Automobiles. What else? Airplanes. Metallurgy. What else? Agriculture? Yeah, maybe. Mining. Yeah. Transportation. You said automobiles and airplanes, but even bigger. Railroads. Roads. Airports. Yeah, interesting. Computers. Yeah, computer field. How about entertainment? Movies. Music. Yeah. Medicine. Yeah. Medical machinery. It's all possible, all with mechanical engineering. So I'd like to say, this is my quote, so you can tell everybody you heard this from me. Mechanical engineering is the liberal arts of does that mean? What does liberal arts mean? Who knows what liberal arts means? In a traditional Western education, students studying something called liberal arts. Liberal arts means that you learn a little bit about everything, and most importantly, you learn how to think. How to think clearly, how to think critically. Think critically means that you don't automatically believe everything you hear. You evaluate what you hear versus things you already know. Make sure that it makes sense, that it's true. Okay, you have to be a good consumer of knowledge. Not a passive consumer, active consumer of knowledge. And that's the idea of liberal arts education. In the old-fashioned version of liberal arts, people studied literature, philosophy, those kinds of subjects, right? History, politics. I say, in the 21st century, where we live today, something that covers the whole world, mechanical engineering. Mechanical engineering is the liberal arts. Because we're sitting in a room right now that this thing is on, right? Mechanical engineering. This thing is on, mechanical engineering. That camera is full of machinery, it's mechanical engineering. Right? Some factory produced this blackboard, it produced the chair you're sitting in. It made my shoe. It made my belt. It made my glasses so I can see you. Right? Made this chalk so we can write. Mechanical engineering is everywhere. So I think you made a good choice. Okay. Now I'm going to quote somebody else. This was my quote. I'm going to quote somebody else a little bit more famous than me. A guy named Theodore Parker. Theodor von Karman said something like this in German. Right? The translation into English is always a little different depending on who you ask. So this is my version of it. Scientists study what is. Right? What's the difference between a scientist and an engineer? Engineer creates what is not yet. Take all the scientists in the world, send them out all around the world into all the forests, all the deserts, all the oceans, and they won't find a fan. They'll find wind, and we all know that wind is really nice when the weather is hot. So what did an engineer do? An engineer created wind. Scientists could go farther north or farther south, get a little bit into a cooler area maybe, discover that it's a little bit cooler, it's not so hot today. Here, I kind of like this. What did an engineer do? He created cool. Air conditioner. It's cool. Two different ways it's cool. It's cool because it's cool, but it's also nice and cool. In the morning, the sun comes up. It's very nice. You can see things more clearly. At night, the sun goes down. You can't see much. What did an engineer do? Yeah. Okay, so that's what we're all about. That's what engineering is. Engineering is art. It's creative. A very famous analyst in the United States, after the United States landed humans on the moon, and they walked around on the moon, and then they got back in and they came home, and they were okay. We did it. Right? Unbelievable. It is unbelievable. He said, this is the most creative thing, the most artistic thing humans have ever done, is to send another human being to the moon and bring them back successfully. It's unbelievable. The spacecraft had millions of parts. Every one of them was designed from scratch, brand new by a human. It was made of thousands of materials. Every one of those materials was produced by a human somewhere. That doesn't exist in nature. Produced it. The pieces of those materials, the elements, were mined out of the ground all around the world, brought together, heated, hammered, mixed, just to produce the material to produce a spacecraft. Someone figured out how much oxygen they need, how to deliver exactly the right amount of oxygen. Too much, you're dead. Too little, you're dead. Just the right amount, you're still alive. How much can they eat? And what happens at the other end? Somebody figured all of that out. It works. It's amazing. It's amazing. And it's all created by engineers. Engineers creates what is not. Engineering is art. And art is design. So that's what we're going to do. We're going to design. Congratulations, artists. You can call yourself an engineer, but you could also call yourself an artist. You're going to be an artist. So the first thing that I really want to convey to you is very simple. Neither me nor any other professor that you'll ever have can possibly teach you everything that you need to know to be a successful engineer. Right? Most of your success is going to come from here, from yours, not from mine. So we'll help steer you. Some of the details that you need to learn in order to get things to work. We can help teach what worked in the past, but you're going to create the future. Okay? The program for mechanical engineering is intended to be an education, not training. Training is when I tell you exactly how to do something, and you do it exactly the way that I told you. Education is when I tell you what I know about it, and I encourage you to understand that I don't know everything, and you will never know everything either. But you will learn a lot of things on your own, and you'll create a lot of things on your own. The education is a base. It's not the answer. Okay, so we're going to do engineering design. So painters, writers, other kinds of artists, they're usually motivated by just creating something that looks nice, sounds nice, and it's music. But engineers like to make stuff that works, right? Like this. So, what kinds of motivations or what kinds of influences affect successful engineering design? Human need. Right? Human need. What do humans need? We have a lot of problems. Humans are very easy. So engineers help humans. What are some human problems that engineers can help with? How about water? For 1 million years, how did humans get water? They walked to a river. Right? Maybe if it was raining, they could get that. How do we get water today? Go to the bathroom. Right? It's so easy. How did that happen? It wasn't nature. some engineer figured out how to do that. They actually figured it out a long time ago, thousands of years. So we make pipes, water comes through the pipe, we figure out how to put pressure in the pipe so that it flows where we want it to go. We produce valves, right? We can open the valve, let more water, close the valve, less water. We have pumps to produce the pressure, right? So lots of engineering pieces have gone into that. Who knows something about the pipe? Why are most pipes round instead of square, for instance? Okay, let's do one. I'll just say one. Who wants to get it? You?
I think the origin is strong. You make the same mass of material, and the second thing is with the same mass of material can make the big area in the circle instead of the square.
That's right. Yeah, those are two very good reasons. So one, that's a very strong shape. Okay, in a later course, when you learn how to calculate material stresses, you can discover that a round shape is a nice strong shape. And it also requires the same strength all the way around. It's even. If it's square, it needs more strength in the corners. Another good reason, very good reason, is if I want to make a long pipe, thousands of miles long, to cover all the houses, right? It takes a lot of material. And if I make the shape round, I get a bigger area for the same amount of material than if I make the shape square. The material has the circumference around the outside. So the distance around a square is longer than the distance around a circle for the same area. That's excellent. Okay, there's another reason too that has to do with the way the water flows. Something you'll learn later when you learn more about how water flows. Water has something called a boundary layer. Inside of the pipe, the water molecules that are right next to the pipe never move. Okay? The ones next to them slide over them a little bit. The ones next to those slide over those a little bit more. Finally, when you get far enough away from the edge, they all move together. But between the ones in the middle that all move together and the edge, there's no motion. So in between there is a layer where some go a little bit faster, some a little bit slower. Down at the bottom, no motion at all. All of that sliding is friction. And friction takes energy. So it wastes a lot of energy to have too much friction. Well, it turns out a round pipe has less than a square pipe. So the water can go through better, too. So it uses less materials, it's stronger, and the water flows better. Who knew that? Engineers figured it out, right? Maybe they didn't know it at first, but they figured it out. Now, engineers, I keep drawing a contrast between engineering and science and nature. But actually, a lot of the things that we know, we learn from nature. Our human body is full of pipes. We have the same problem. We have water, blood, right? It has to flow through our body all the time. Right? Our body wants to be as efficient as possible. What shape are our blood vessels? Yeah, right? So nature already figured this out. Nature does it the hard way. Nature tries over and over and over again. Dinosaurs, amoebas. Each thing that's successful then produces more species later on that are also more successful. And finally, you end up with something like humans. And it must be a good idea if it's a human, right? So, okay. All right, so water would be one need. What's another human need? Food. How did humans get their food for 1 million years? They went in the forest and they found it. They picked it up. If it was running around, maybe they threw a rock at it, trying to kill it, catch it somehow. All right, how do we get most of our food today? It's from agriculture, right? Agriculture is all engineering. We prepare the soil, we prepare the plants, we bring the water, we have to harvest, collect the crop, process. Right? It's full of engineering. Agriculture is full of engineering. All of the early engineering, or almost all of the early engineering was agriculture. Right? Human existence changed with the invention of agriculture. It's fascinating. When the job of humans was to gather all the food in the forest, there's no motivation to gather more than what you can possibly use, because if you take too much today, it won't be there tomorrow. So you take only as much as you can eat today. And then about 10,000 years or so ago, someone realized they could grow some things and have some agriculture. Now they can produce as much as they want. There's no negative part. If I'm a hunter, there's a negative part if I'm too good of a hunter, because then I kill all the animals and I starve. So if I'm a hunter, I only kill one that I need, and then I quit hunting. But if I'm a farmer, why not keep producing as much food as possible? And what happened to human population? It took off, and only about 10,000 years ago. Only about 10,000 years ago. Because now we can produce as much food as we want. We also now have a concept of economics. Right? In the old days, there was no economics. I just went and got food when I wanted it. No reason to get any more. Now, though, if I can produce more of something that I need, I take it and I can sell it and trade it. And I can get a new shirt, I can get a computer, I can get a television. Right? So now humans are producing huge amounts of economic value. It only started maybe 10,000 years ago. Before that, nobody bothered. There's no reason. It's fascinating, change in sociology. This also began a huge need to produce better and better tools, more and more engineering. Okay, what else motivates human? Air? Okay, you can say air. Okay.
Connection.
Okay, energy. Communication. Medicine. Right? Let me say, I'll just say health. In general, right? Sorry. Education? Yeah. Okay. Let me add one. Not all engineering is designed just to satisfy somebody's need, like water, right? Why do you have an MP3 player? You don't need it. But there's some really rich guys out there that because you want it, right? So that's profit. Something along the lines of communication, right? We talked about it earlier. I think it's a big one. Try to imagine all of the engineering that goes into modern movies. High-tech cameras, animation, sound, then making copies to distribute all around the world. It's amazing. A lot of engineering. The lights, the recording. Okay, what else? Fair, right? It's sad, but it motivated a lot of engineering. Politics. How does politics affect engineering? Yeah, they create laws for one thing, right? So One common thing nowadays, right, are environmental laws. So humans, for instance, we like to have our lights, we like to have the air conditioner, we like to have the fan, we like to have the television, so we need electricity. Humans know how to produce electricity, but in a lot of ways that damage the environment. Now, because of new law, we have to invent some new ways to produce electricity that won't damage the environment. Burning coal is easy. We've done that for 200 years. We know how to burn coal. But it's very dirty. So now we switch maybe to photovoltaics. We're not very good at that yet. We need to be better at photovoltaics. Nuclear energy. 50 years ago, 70 years ago, we figured out how to use nuclear energy for electricity. But it still has some problems. What do we do with it? What happened in Japan? It's very sad. So. Okay, what else? We need a list of this. Transportation, I think, is a big motivation. I believe, I'm not certain, but I believe that the biggest industry in the world is automobiles. All around the world, millions and millions and millions and millions of automobiles. Manufacturing. So manufacturing is parts of most of these things, but it's a separate, I think it's worth mentioning as a separate category. Because it's one thing when you're a child, let's say, and you're sitting in class and the teacher's boring, and so you draw a picture of a spacecraft or something on a piece of paper, you know, or maybe it's a rocket ship or submarine or something cool, you draw it on the paper. It's great to have that idea. But in order for it to become a product that everybody can use, it has to be made in such a way that somebody can build it. It can be manufactured. So I used to work for a Chrysler company. It's one of the big car companies in America. And here's how they designed a car. How do you think they designed a car?
They use clay to make the shape and then they design and then
Yeah, that's exactly right. Did everybody hear him? They have a big studio. They have a sculptor. They take a big piece of clay, and he takes a sculpting knife, and he carves the car until it's really beautiful. Then they have a bunch of business people that come in, artists and other people, and they walk all around and they study it and they look, and they decide if they think this is really a beautiful car, people will want to buy this car. It looks really nice. Everybody will want this. Right? Then they go and they have some test groups of consumers. They go out in the community, pick people at random, show them pictures. Do you like this car? Does this look nice? Would you buy this car? If it gets to that point, they decide, yeah, this is good. We would like to make this car. Then they bring in some engineers and they say, okay, turn this into a car. Figure out how you can fit the engine in there. How are you fit the seats in there? How are you going to get the steering wheel in there? How do you get the air conditioner? How do you get the CD player? Everything comes last, not first. Okay, so that's manufacturing. It's an art by itself. I see this beautiful shape. I'd like to drive this thing, but it's just a piece of clay. Turn it into a car. Okay, what else? Manufacturing today also has pieces of environmental science in it, very much. Because we've known how to make cars, for instance, for a long time. But we can go to junkyards and find stacks of old cars, right? Just sitting out in the field somewhere that don't work anymore. And they're junk. So with manufacturing today, we try to produce products that when they're finished, we can then take them and reuse them completely and not produce more pollution. Right? So part of manufacturing isn't just how do I build this thing today, but also how do I build it so that tomorrow it's gone. very, very important. So that's a big challenge in manufacturing. All right, what else?
Information technology.
Okay, security. Sure. Yep. So you had one
That's information technology.
information technology. Yeah, that's probably communication, entertainment, but let's say information. Does everybody know the name Gutenberg? You know this name? He's the German that was credited with having invented a printing press. Before that, books were copied by hand, one at a time. So books were very rare. Most people couldn't possibly have one. They're too expensive. And then he invented a machine that you could make copies over and over again and have thousands of books in the same book. Instead of copying them one by one. How big a change in the world was that? Maybe one of the biggest changes ever in the history of the world. Now we can all have copies of every book. It's easy. In fact, it went beyond that, as we know, because between entertainment and communication, right? We now have the internet, and you can get any book online. You don't even need to have a printed copy. You just read it electronically. It's amazing. It really is truly amazing. Right? It's difficult when you live in today's time to realize how big a change was for most of humans and most of history to your life today. How much different your life is. Your ancestors' lives were completely different. It's amazing. Engineering. Good ideas? Create the world that has not been. Create the world that has not been. You're going to make a new world. Every day. Okay. How are we going to do this? We have these great ideas. Science, right? So, as I said a minute ago, it's a great thing that you can sit as a child in your class. The teacher's boring, and you draw a picture of a cool submarine or a rocket. But in order to make it work, you need to know something about science. Hey, I've got this great idea. Wouldn't it be wonderful if, instead of having to walk to the river every time I want to get a drink, I could have something in my house. I just turn the faucet and water comes out and I can drink. Wouldn't that be wonderful? Right? Great idea. How am I going to make it work? Wouldn't it be great instead of having to walk every time I want to go to Hanoi, it takes me 3 days, if instead I had this thing I could just sit in 1 hour later I'm in Hanoi. Oh, that's a great idea. How am I going to make it work? Okay, so on the one hand, the goal of engineering is art. The goal of engineering is art. The practice of engineering requires some science. Okay? And underneath science, there's another fantastic human invention called mathematics. We invented mathematics. Humans did. Congratulations. Nice job. It's an amazing thing. Mathematics is an amazing tool for being able to describe the world and create rules or discover rules that seem to work in the world. Right? The world doesn't exist as an equation. The world is air, it's molecules, it's chemistry. But we can write equations that actually work. They work. It's amazing. Right? We invented that. Nice job. So we study to get ready to do this design. We need to learn a lot of mathematics, and that's part of learning a lot of science. Right? These two go together. What else do we learn?
Physics.
learned some, well, I had physics as part of science. This would include physics, chemistry. Those are the two most obvious. If you want to do medicine, a lot of mechanical engineers do medicine. Maybe learn some biology, maybe some anatomy. If you want to do agriculture, you probably learn some botany, and so on. Three, etc. because there's a lot. Okay, math. We're shaped by economics and business. Okay, let's go back to our submarine or our rocket ship. That really cool thing we drew when we were in third grade. Right? Now you're an engineering student. Now maybe you learned enough that you actually could build it. You could build that rocket ship, you know enough. But you need 1,000 materials and they cost a lot of money. So it's going to control the economics. The economics in the business will control whether or not you're able to do that. You could have a great idea for the next great car. By the way, one thing I want to mention about cars. You know, cars, one of the things that I think is amazing about cars, you could go to a big parking lot, say at an airport or a shopping center, right? Look in the parking lot, and how many cars do you see that are exactly the same? Not very many, right? You see thousands of cars, hundreds of cars, or thousands of cars. They're different colors, they're different size, they're different shape. Some have 2 doors, some have 4 doors, some have a door in the back, some don't have a door in the back. Some are a little higher, some are a little lower. How can that be? It's the biggest business in the world. There's all this money out there. Trillions and trillions and trillions of dollars if you could design the world's greatest car. So everybody in the world tries. There are car companies, everybody's trying to build the greatest car and sell the most cars. And yet, go stand by the side of the road and watch them go by. They're all different. How can that be? How come there isn't one great car that everybody wants? How come there's 1,000 different cars? How come? Because everybody's need is a little different. Yeah, everybody's idea is a little bit different. Why are there 100 different MP3 players? They all do exactly the same thing. I like this one. This one's cooler than yours. Cell phone, right? Who has the same cell phone? Everybody hold up their cell phone for a minute. Let's see who has the same one. Mobile phone. Yeah, so far I don't see any. None of them are the same. Okay, so how is that possible? You all want the same thing. You want a nice phone. You want to do maybe some email, listen to some music. Everybody wants the same thing, but you have different phones. How is that possible? That's how it's possible, right? Engineering isn't just about making something that works. It has to compete in the economic world. It has to compete in the business. Why do you have 20 different phones? Because everybody out there knows there's a huge, huge amount of money to be made with phones. If I can sell even just a few phones, I'll make some money. So everybody tries, and there's so many different phones. And it works, because look, you all bought different phones, right? So it works. Okay. Politics is huge for a lot of engineering. It's huge. The biggest engineering projects are always public projects. Road, dam, airport, electric system, power production. It's always a public project. And who decides what's going to be made in a public project? The government. So a lot of engineering, Did I say a lot of engineering is controlled by the government? They will decide which project gets built, which project doesn't get built. You have to convince them. And that's a political decision. Right? So the two biggest factors really are economics and business and politics. Every once in a while, some hero individual engineer someplace by himself or by herself can create something that's brand new and is very successful and makes a big impact on the world. But most of the time, it's going to come from either government project or some big business project. That's the thing that's going to drive the engineering. Okay, what else? You know this word? Aesthetics? Aesthetics is a general word that refers to whether you think something is very beautiful and pleasing, nice to look at. Okay? So my car that's 15 years old, I think it's fine. It works fine for me, but I'm kind of blind. My wife thinks it's really ugly. So for her, the car does not satisfy aesthetics. For me, it satisfies transportation. But for her, it doesn't satisfy aesthetics. Okay? That's a good motivation. There's a lot of things that work perfectly fine, but they're not very beautiful. So why not make another one, a better one, that even if the only way that it's better is because it looks a little more beautiful. Like this desk. I'm going to guess, I don't like to pit boys against girls, but I bet that most of the boys in here think the desk is fine. And I bet most of the girls in here think that the desk is kind of ugly. Is that right? Okay, well, if you could make a more beautiful desk, maybe some more people would want to buy the desk. Does it work any better? A desk, it's fine. If you're just going to write on it, why not? It's okay. But if it looked a little more beautiful, why not? Okay, so aesthetics is one. What else? So aesthetics is when it looks better, but it doesn't work better. Another one is better performance. I'm old enough that I remember the beginning of computers. When the first computer came out, everybody was amazed. And then a computer came out that was a little faster, a little more powerful. Everybody was amazed again. And then it happened again, and it happened again, and it happened again. And today, the computer that you have in your cell phone is more powerful than the one that went to the moon and back. Right? So why? Why keep making a new computer? We went to the moon. Let me just remind you, if you don't know this. Who knows what year we went to the moon? Yeah. We what? 1969. 42 years ago, humans flew to the moon. 42 years ago. We could do that. We already had the technology to do that. We already had good enough computers to do that. Okay, so why didn't we quit? Why do we need a better computer? We have a computer that can take us to the moon and back. 42 years ago. That computer wouldn't even work in your cell phone today. You wouldn't have a chance. It couldn't do anything. In fact, in those days, the telephones, they had the dials. They weren't digital. They were analog. In fact, a lot of telephones in those days had no line at all, no buttons. You pick up the phone, and it goes to an operator, a human. And you say, I want to talk to Bob. And the operator takes a wire, 2 wires, and connects them. And now you talk to Bob. When you're done, they take the wires apart and put them back in the thing. Okay? I know it sounds funny, but that's how telephones used to work. But it worked. right? I can make a phone call. Why do I need a new telephone? I have one that works. Well, we always want something that works better. We always want the latest thing. How many of you have had more than one mobile phone in your life? Is that your first mobile phone? No. Is it your second mobile phone? No. How many have had 3 mobile phones? 4. Yeah, see? Why? I think it's both of these, probably. The new one is more beautiful, and it works better. Okay, so we don't always have to create something new, even though we're artists, and artists need to create new things. The new things we create aren't always very much different from the old one. It might do exactly the same thing, but it either does it more beautifully, or it does it better. It just performs better. It's faster. It's smarter. It has more memory. Something like that. Whatever it is. Okay. Anybody have any questions? Or comments? All right, so now what I want to do is I want to give you some things to work on your own, and then we'll meet again. This class, the current schedule that we have for this class, it shows, I think, 28 meetings for 2 hours. That's a total of 56 hours. This course on our campus meets for only about maybe 15 or 20 hours. Okay, so we probably won't fill all the 56 hours with our meetings, but the class also includes a lot of work outside of class. In fact, at Buffalo, the rule usually is so you've chosen to follow this program called the Advanced Program. It's modeled after U.S. engineering schools. In the U.S. engineering school, the normal ratio is that for every hour that we spend inside of class, you should spend 2 or 3 hours outside of class working on your own. Okay? I don't think I'm going to be that demanding. I think the things that I'm going to give you to do won't take you that long. But to make it a little bit easier on you too, I'll cut down on this part. So we won't spend quite as much time in class. So I'm going to give you an assignment. What I'll do with most of the assignments in the class is I'll make it due 2 days later. So the next day you can come in and we can discuss it if you need to. And then the next day you have to give it to me. Okay? So this is Monday. I'm going to give you an assignment now. You should turn it in on Wednesday. Okay? I hope that this will be fun for you. Okay, just a second, please. I hope this will be fun. I hope everything that you do is fun. I hope when you choose a career like mechanical engineering, you have fun, right? Enjoy yourself. Not every minute of every day. Sometimes it's hard work, but most of the time it should be fun. So I want you to create. One other thing I want to mention. In the modern engineering world, it's not all about having just technical expertise. It's not just about math and science. You have to be able to communicate. You have to be able to work with business people, work with politics, as we saw. And usually, nowadays, you have to be able to work internationally and communicate. So you have to be good at all those things. And I'm going to force you to do a lot of communication. Okay, so you're gonna write for me, and you're also going to make presentations for me. Okay? But here's the first writing assignment. So I want you to prepare 2 lists. Okay. The first list is, I want you to think of 10 products. Be very creative. Think about it. 10 engineering products that you know of that mimic something that exists in nature, but they do it better. Like, for instance, this thing mimics wind. Wind is really nice in nature because it helps cool you off. But it's not reliable. Some days there's no wind, and it's pretty hot. So this is nice because it mimics wind, it mimics nature, but it does it better. You can start it whenever you want, turn it on whenever you want, you can turn it off if you don't want it, you can make it higher, smaller, bigger. Okay, so a fan would be an example of that. Does everybody understand? Okay? Then I want you to also make a list. This one I think will be a little bit harder. I don't want to say they don't exist. None of them exist. Okay? 10 engineering products that are not based on nature. Something that a human invented. Some human being invented it, thought about it, and invented something that we use now, that we really like. But it doesn't even exist in nature. It's completely human invention. Like, for instance, an MP3 player. Right? An MP3 player records sound. For 1,000,000 years, if you wanted to talk to somebody or hear somebody else talk, you had to go get next to them and talk to them. If you wanted to hear music, you had to go stand next to a musician while they're playing music. Now with the MP3 player, you can listen to somebody that you will never meet in your life. You can hear speech from people. You can hear the speech of somebody who died before you were born. Right? It doesn't exist in nature. So that's just one example. I'd like you to think of 10 other products out there, 10 things that humans have invented that don't copy something that exists in nature, that's something completely new. Okay? It's a little bit harder. It's a little more creative. The humans that invented these things were more creative in some ways, right? And it's going to be more difficult for you to think about. Okay. Now let me see here. We've got 12, 17, 22, 27, 32, 44, 60 streets. Wow. Part of me, yeah, please keep listening for a couple minutes. We're gonna end early today. Okay, so you'll get some extra time. You can talk after, but listen while I'm still here. So I want to tell you what I'm thinking about, and I want to hear what you think about it. So I'm thinking that it's a good idea in general to have group work together. I think it's good for everybody if you exchange ideas and you get to think together. But I'm worried because in a group, when you let a group work on something, the work normally doesn't get evenly distributed. One or two people end up doing all of it, and some people are lazy and they don't do anything. So I know. So I want to ask you the question, do you want to work on this project? What do you think about working on this project as an individual or work on it as a group?
The group that we met.
Yeah. Yeah, this is, I'm using the word project and assignment to mean the same thing today. Okay. Individually? Yeah. I think this one we'll do individually. I'd like everybody to think about it on their own. Okay? So this one is individual. We'll do some group projects later. Okay, does everybody understand what I'd like you to do? Yes. I'd like you to have fun while you do it. Okay, really think. Really think. Don't do, you can do some that are obvious, because to do 10 is going to be difficult. So it's okay to do one or two that are obvious ones. But try to imagine something that you don't think the other people will imagine. And so when we come back on Wednesday, We'll go around the room a little bit and we'll write some of them down and we'll see who can think up something that's really clever. Okay. Yes. Yeah, thank you for that. I'd like you to give a little explanation. Okay, when I said make a list of the product, I also would like, thank you for reminding me, I'd like you to explain, for the ones that mimic nature, just explain the function of the product and why you say it mimics nature. So I use the example of a fan. So what I would expect you to write is, a fan is a product that mimics wind. Right? So that's the explanation, mimics the wind. And for this one, you can explain the function. That does not exist in nature. Right, so for this one I use the example of an MP3 player. Right? An MP3 player records sound, makes a sound recording, so you can listen to somebody's speech 20 years later or listen to music. Right? There's nothing like that in nature. So explain the function that's not in nature. Okay? Some of them are sort of in the middle. Like I'll mention airplane. Right? Would you say an airplane mimics something in nature or doesn't mimic something in nature? So some of each kind of, right? Because there are things that can fly, but they normally don't carry passengers around. So, okay, any other questions about this? All right, good. I'll see you tomorrow at 1 o'clock. Please be on time.